Welcome to this section on double angle, half angle, and product sum formulas. Let's look at the first example. We're asked to use addition formulas to write cosine of 2x as an identity in three different ways. So I need to prove the first one, that cosine of 2x equals cosine squared x minus sine squared x. I know that the right-hand side definitely looks a little bit more complicated than the left-hand side, but I'm going to use the addition formulas, and so I'm actually going to show that the left-hand side can equal the right-hand side. So the first thing I'm going to do is rewrite cosine of 2x as cosine of x plus x. And then I'm going to use the addition formulas to rewrite cosine of x plus x as cosine of x times cosine of x minus sine of x times sine of x. So that gives me cosine squared of x minus sine squared of x. And that is exactly what I have on the right-hand side. Cosine squared of x minus sine squared of x on the right side as well. And so I've proven that as desired. Let's take a look at cosine of 2x equals 1 minus 2 sine squared of x. If I know from the previous example that cosine of 2x is equal to cosine squared x minus sine squared x, then I can replace this cosine of 2x with cosine squared x minus sine squared x. And then from there, I know that just off to the side, we'll write this over here. Sine squared x plus cosine squared x equals 1. I know that from way back. So I could replace the cosine squared x with 1 minus sine squared x, because if I subtract sine squared x from both sides, I'll get my cosine squared by itself. Therefore, I can replace the cosine squared x with 1 minus sine squared x, because those are equivalent. And there, when I substitute that in, I'll get 1 minus sine squared x minus sine squared x, which simplifies to 1 minus 2 sine squared x, which is what we wanted to show. And so the cosine of 2x is equal to 1 minus 2 sine squared x. And we have proven this to be true as desired. Let's look at prove cosine of 2x equals to cosine squared x minus 1. Well, from the previous example, I can recall that cosine of 2x is equal to cosine squared x minus sine squared x. And I also can remember that since sine squared x plus cosine squared x equals 1, if I'm looking for 2 cosine squared x minus 1, I have to be able to do some sort of substitution. But instead of replacing the cosines, I'll replace the sines. So I'll subtract cosine squared of x on both sides, and that will give me a sine squared x equals 1 minus cosine squared x. Therefore, I can substitute the negative sine squared x. I can replace the sine squared x with 1 minus cosine squared x. Now, don't forget that negative sign in front, because if you forget it, everything gets all messed up. After I replace it, I'll have cosine squared x minus 1 plus cosine squared x. And if I combine my cosine squared x's, I'll have 2 cosine squared x minus 1 is equal to the other side, the right-hand side, 2 cosine squared x minus 1. And I've proven that one as desired as well. So you can see that there are a lot of different ways to write the double angle, or when you have a cosine of 2x, there's many different ways to rewrite it, and they're all equivalent identities. The next example asks us to find a formula for sine of 2x using the addition formula. Well, let's go ahead and rewrite sine of 2x as sine of x plus x. And let's recall what the rules for sine when we were adding them. We know that sine plays well with others, so we had sine x cosine x. The signs stayed the same, so if it was a plus here, it would be a plus between the products. And then cosine x sine x. If you recall, multiplication is commutative, so it doesn't matter which order the sine x and cosine x are multiplied to each other. Since the angles are exactly the same, we can rewrite this as 2 sine x cosine x. And this is actually a perfect formula. This is a sum that becomes a double angle formula. It's quite nice. I was not asked to prove this. I was just asked to show what I could do to find a formula for two angles added together that are exactly the same size. And now we're asked to find a formula for tangent of 2x. So we'll do the same thing over again. Remember that if you have two angles for tangent and you're adding them together, we take the tangent of the first plus the second. That gives us tangent x plus tangent x. And that is divided by 1 minus tangent x times tangent x. If I simplify that just a little bit, I'll have 2 tangent x over 1 minus tangent squared x. So I have a surprise for you now, because what I just did is I showed you how to get the double angle formulas using the addition formulas. And I think that's pretty cool. So if you can't remember these, you can always remember that the sum of two identical angles is 2x, and then you can derive all these formulas here from what I just showed you. The formula for sine is sine of 2x equals 2 sine x cosine x. The formula for cosine is cosine of 2x equals cosine squared x minus sine squared x, or 1 minus 2 sine squared x, or 2 cosine squared x minus 1. And the formula for tangent, as we just saw, is tangent of 2x equals 2 tangent x divided by 1 minus tangent squared x.